Hello and welcome back. Today we're going to take a look at the addition and subtraction of complex numbers and their multiplication of certain different forms. First, let's start with their addition and subtraction. Now, in order to subtract or add them, all you have to do is just treat them like a variable. Like the I, the imaginary unit, you can treat it like a variable. So you're just going to group the like terms as the first step. So I'm just going to bring the numbers next to each other. That's 4 plus minus, that's going to give you -4. And then you have -3i plus, this is actually a plus right there, plus 3i. So you're going to get 0 minus 0, which is 0. So far, so good. Same thing for the other one. You just group the like terms. So you get 1 minus 3, right? The 1 and 3. And then 5i minus 2i, right? The two minuses give you a positive. So you're going to get 5i plus 2i, leaving you with -2 plus 7i. All right, so that was really simple. Now, what happens when you multiply two complex numbers or when you're just going to expand them in some way? First, I'd like you to give you a bit of a reminder. So here is the reminder. If you guys recall, I, which was the imaginary number, is essentially the square root of -1. Now, if you square I, raise it to the power of 2, you're going to have essentially square root of -1 times square root of -1, right? And according to the rule, the square root of a times square root of b, you can write this as the square root of a times b. Okay, what else? So that means I can write this as -1 times -1, which becomes raised to the power of 2. The 2 and the square root then cancel each other out, leaving you with -1. So I square is equal to -1. All right, this is a fact. Now, keep that at the back of your mind. Let's go ahead and take a look at some examples. Example 1. Let's go ahead and multiply, for example, 3i times -5 plus 2i. How do we deal with this one? All right, in order to do this, all you have to do is remember, if you remember the rule from the distributive law, you just have to multiply 3i by -5 and then by 2i. So that's going to give you -15i plus 3i times 2i, that's 6i squared, right? Now the -15i can't really be simplified any further, so you just have to leave it as -15i. But the 6 can be simplified as I squared is what? It's equal to -1, right? So you can multiply with -1, and the final answer is -6 minus 15i. All right, that was simple. Let's go ahead and take a look at another example. What happens if we have something like this? B, 4 plus 3i multiplied by -1 minus 2i. Now, first of all, if you guys remember the expansions from algebra, so like things like, a plus b multiplied by a minus b, where you had to use the FOIL or basically just use the distributive law, so it's just a times a and then a times -b, and then b times a and b times -b. The same thing actually applies here. So you're going to multiply 4 by -1 and then -2i. And then the second term, which is 3i, is basically going to go through the same process, multiplied by 2i. So that's going to give you -4 minus 8i minus 3i times -1, and then 3i times -2i, which is plus 6i squared. That's going to leave you with essentially -4. The 8i minus 3i is going to give you essentially 11i plus 6 times I squared, which is 6 times -1. So you're going to have -6 minus 4, that's -10 minus 11i. All right. So these are basically the basic simple steps that you can take to do these. Let's go ahead and do another example just to be sure. So C, for example, -6 plus I multiplied by -6 minus I. All right. Same process. So -6 times -6, and then -6 times I. And then the second term, I times -6, and then I times -i. So you're going to get positive 36 minus I times -6 becomes positive 6i. All right, positive 6i plus 6i, my bad, minus 6i, because positive I minus 6 is going to give you minus 6i. And then positive I times minus I, that's going to be minus I squared. All right, so 36, this is 0, minus 1 to the power of 2, right? Actually, not to the power of 2. See, that's a mistake that you can make, right? Because I squared is actually negative 1. So don't do that. So you're going to get negative 1, since I squared is negative 1, and negative times negative is going to become positive. So 36 plus 1, that's 37. All right. Now, so remember this. Whenever you're multiplying, as you can see right here, negative 6 minus I was the conjugate of negative 6 plus I. If you forgot what a conjugate is basically the opposite of the other term. So basically, we come to a conclusion. The product of two complex numbers, or of complex conjugates, basically, of complex conjugates, this is a good thing to know, is a real number. Wait, what? Once again, the product of a complex conjugate or complex conjugates is a real number. Over here, the conjugate of negative 6 plus I is actually negative 6 minus I, right? Another example, for example, if you had negative 5 plus I, the conjugate of this would be negative 5 minus I. Or the conjugate of, for example, positive 5 minus I would be 5 plus I. So it's basically the opposite. So anyways, the product of complex conjugate is a real number. What does that mean? This means that if I multiply a plus bi, the original complex number, by its conjugate, which is a minus bi, what I get is essentially, I can go ahead and expand this, but this is just going to give you a squared plus b squared, which means that it's not going to have any imaginary numbers in it. So it's all going to be real numbers. And in fact, I have a example, which is right here, C, to prove that. When I multiply the conjugate of negative 6 plus I by its conjugate, I got 37, which was a real number. All right, that's it, and thank you for watching. In the next video, we're going to be covering the same topic, but then we're going to be talking about the quotients and their divisions of complex numbers. Thank you for watching, and stay tuned.